We developed the radar system, the robotics assembly by demonstration via augmented reality. This system empowers human-robot collaborative assembly tasks through the use of digital twins. In manufacturing, full automatic robot assembly often falls short of human efficiency due to limitations in understanding task complexities and the environment. They struggle with high-level assembly task planning and complex assembly steps, like peg and hole operations. To address these challenges, integrating human involvement into robotic assembly is a promising strategy. Therefore, we presented the radar system. Radar is built on a 5-layer digital twin framework, offering an intuitive augmented reality interface for users. Even those without robot programming knowledge can use it effectively. The AR interface includes a course task planner panel, allowing users to inspect and modify task management easily. Users can physically demonstrate the virtual robot's actions, selecting target objects and specifying grasping orientations. They can also manipulate virtual widgets and buttons for precise operations like peg insertion and beam assembly. To test the radar system, the ramp assembly benchmark is used. It simulates off-site construction with steel-rolled beams. 9 evaluation metrics across 4 subtask scenarios are considered. At each evaluation, we compared the action provided by radar with the ramp baseline with at least 15 trials. We focus on completeness and execution time as performance metrics. From the result, the involvement of human in the loop significantly enhances the execution accuracy and efficiency. The radar system incorporates a task planner framework that takes human factors into consideration. Our research shows that involving humans in the process significantly improves the precision and success rates of robotic assembly operations.